Encapsulation is a fundamental process in networking that involves bundling data with protocol control information to transfer data between hosts and across heterogeneous networks. We use either the OSI or the TCP/IP model in our network, and the data transmission takes place through various layers in these models. The following figure represents encapsulation and de-encapsulation. Encapsulation in network models. Advantages and disadvantages. Here are the advantages. Enhanced security. Advantage. Encapsulation provides a level of security by hiding the internal details of each layer. Explanation. Attackers may find it more challenging to exploit vulnerabilities in a specific layer without knowledge of the encapsulated data. Isolation of layers. Advantage. Layers can operate independently without knowledge of the internal workings of other layers. Explanation. This isolation enhances security and simplifies troubleshooting, as changes in one layer do not affect others. Now for disadvantages. Complexity. Disadvantage. The layered structure and encapsulation mechanisms can introduce complexity. Explanation. Understanding and troubleshooting encapsulated data may require a deep understanding of the entire network model, which can be challenging for some. Resource consumption. Disadvantage. The encapsulation process consumes additional computing resources. Explanation. In resource-constrained environments, the extra processing required for encapsulation may impact overall system performance. Amplitude shift keying (ASK) is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of a signal. Any modulated signal has a high-frequency carrier. The binary signal, when ASK modulated, gives a zero value for low input while it gives the carrier output for high input. The following figure represents ASK modulated waveform along with its input. Amplitude shift keying (ASK), advantages and disadvantages. Here for advantages. Simple and easy to implement. Relatively low cost compared to other modulation techniques. Now for disadvantages. Low data transfer rate compared to other modulation techniques. Susceptible to noise and interference. Applications. Here comes a wide range of applications of ASK. ASC is commonly used in wireless communication systems, such as keyless entry systems, remote controls, and radio frequency identification (RFID) tags. In optical fiber communication, ASC is used to transmit digital data over long distances. ASC is often used in digital broadcasting, including television and radio transmissions, for transmitting audio and video signals. ASC can be used for low to medium data rate communication, such as in binary data transmission over short distances. ASC is used in medical telemetry systems for monitoring and transmitting patient data. It is a simple flow control protocol that allows only one outstanding unacknowledged data frame at a time. Stop and wait is a basic automatic repeat request (ARQ) method that ensures reliable in-order delivery by only allowing one frame to be sent until it is acknowledged before sending the next. The following figure represents stop and wait. Stop and wait protocol. Error control, advantages and disadvantages. Let's see for advantages. Simplicity. Advantage. The stop and wait protocol is simple and easy to implement. Explanation. Its straightforward design makes it suitable for scenarios where simplicity is a priority. Error detection. Advantage. The protocol provides automatic error detection. Explanation. The sender waits for an acknowledgement, ACK, from the receiver, and if not received within a specified time, assumes an error has occurred. Sequential processing. Advantage. Data is sent and processed sequentially. Explanation. Each frame is sent and acknowledged before the next frame is transmitted, ensuring orderly communicating. Now for disadvantages. Low throughput. Disadvantage. Stop and wait has low throughput. Explanation. The sender must wait for acknowledgement before sending the next frame, resulting in inefficient use of bandwidth. Inefficiency in high-latency networks. Disadvantage. The protocol is inefficient in high-latency networks. Explanation. Long round-trip times can significantly impact the communication speed, as the sender has to wait for acknowledgement. Limited bandwidth utilization. Disadvantage. Bandwidth utilization is not optimized. Explanation. The protocol does not take advantage of parallelism, leading to underutilization of available bandwidth. Simple understanding for stop and wait. Sender. Rule 1. Send one data packet at a time. Rule 2. Send the next packet only after receiving acknowledgement for the previous. Receiver. Rule 1. Send acknowledgement after receiving and consuming a data packet. Rule 2. After consuming packet acknowledgement need to be sent, flow control.